Welcome to CE 402 Environmental Engineering 2 Module 3 Part 1. In this session, the complete module covers the topics wastewater disposal system, that is self-purification of streams, dilution method, in that oxygen sag curve, then stripper Phelps equation, then land treatment. In the second session, the treatment of sewage, that is preliminary and primary treatment, then theory and design of screen, grid chamber, Ricketters chamber, flow equalization tank and sedimentation tank. First, we will move on to the first session, that is wastewater disposal system. There are major two methods of wastewater disposal system. First one is dilution system and second one is the disposal on land. The dilution system means the disposal of wastewater into the water, so that is surface water, and the disposal on land means effluent irrigation, broad irrigation and sewage farming. Next, we will move on to the first method, that is disposal by dilution. What is the word meaning of dilution? It is the mixing of this wastewater with the surface water. That is, the concentration of the pollution will get diluted by mixing the wastewater with the surface water. And this effluents, that is wastewater coming after treatment process from ETPs, that is effluent treatment plants, will disposed of into a static water body or a moving water body. Static water body means a lake or something like that. The water is static, and the moving water body like river, lake, etc. And the discharged wastewater, that is the wastewater coming from the effluent treatment plant, will be purified, is purified in due course of time, mixing with this river water, and self-purification will happen due to this dilution or mixing. The effluent discharge and the effluent treatment, that is the degree of effluent treatment, will depend upon the self-purification capacity of the river or the water body. Then, what is a self-purification of streams? When wastewater is coming out of this effluent treatment plant, then the dissolved oxygen content of this wastewater effluent will be very low. And this will mix up with the river water. Then the dissolved oxygen content of the river itself will get reduced and it will affect the aquatic life of that water body. So, this self-purification means when water is mixed with the wastewater is mixed with this river water or the water in the water body, it will thoroughly mixed and it will move from the point of mixing to a large distance from the point of mixing. During this travel, this wastewater get mixed up with the more amount of water, and this DO content will regained by this river water due to dilution. And this self-purification will be different for different types of water bodies, and it will depend upon certain factors. And this self purification of rivers will help the dilution method of disposing of wastewater. And this phenomena, that is the river gets purified by its own, is known as self purification of streams or rivers. Then conditions favoring dilution. The first condition is when wastewater is quite fresh. When the wastewater is quite fresh, it is easy to decompose the organic matter present in the wastewater. And the suspended solids has been removed from the wastewater. That is, before the treatment, all the suspended solids from the wastewater should be removed. And the volume of receiving body is more than the wastewater discharge. That is, the mixing, that is, the dilution should be more by adding more amount of water with the wastewater. And the dilution water having a high DO to satisfy the BOD of wastewater. The BOD of wastewater will be high, and this BOD should be satisfied by consuming the dissolved oxygen content in the dilution water. So the dilution water should be having a high DO. And where the flow currents of the dilution water are favorable, causing no deposition, nuisance or destruction of aquatic life. The flow should happen in a proper way so that the dilution will happen in a proper manner, and no deposition should happen there at the point of mixing, and no floating things will float on the surface of the water body, so that the oxygen entering of oxygen content into the river water is get blocked, and no nuisance should happen, and no destruction of aquatic life should happen in the water body. And the wastewater does not contain any toxic substances. That is, the toxic substances like a chemical pollution should not be there in the wastewater, so that it will affect the aquatic life in the dilution water. And the water is not used for drinking immediately after the point of discharge. That is, the disposal point should be away from the input point. That is, our water supply scheme treatment plant or the input well should be located away from this wastewater disposal point. Then this table shows the standards of dilution. That is, the dilution factor is given in the first column, and the standards of purification required is given in the second column. That is, if the dilution factor is 500, no treatment is required for the wastewater. The raw sewage can directly disposed of into the water body. Then next one is the dilution factor between 300 to 500. Then primary treatment should be given to the wastewater, and the suspended solid concentration should be less than 150 milligram per liter. When the dilution factor is between 150 to 300, then treatments such as screening, sedimentation and chemical precipitation are required, so that the suspended solid concentration is less than 50 milligram per liter. When the dilution factor is less than 150, then thorough treatment, that is primary, secondary and tertiary treatment, are to be given to the wastewater, and the suspended solid should be less than 50 milligram per liter, and the BOD of 5 days should be less than 20 milligram per liter. This is the relation between the dilution factor and the degree of treatment to be given to the wastewater. Then natural forces of purification. First is dilution, then second one is dispersion due to current, then sedimentation, then sunlight, then temperature, oxidation and reduction. Let us discuss one by one. First one is dilution. When the wastewater is discharged into the receiving water, dilution takes place, due to which the concentration of organic matter is reduced and the potential nuisance of sewage will also get reduced. This happens only when the dilution quantity of dilution water will be more compared to the wastewater, and the self-purification capacity of the receiving water body should be high. When the dilution is quite high, the larger quantities of dissolved oxygen are always available, which will reduce the chance of putrefaction and pollution. Then aerobic conditions will always exist because of dilution. These aerobic conditions will enhance the process of decomposition of organic waste in the wastewater due to the mixing up of dilution water with the wastewater. Then dispersion due to current. This is when strong water current is available, then the dispersion or the dilution will be more. The discharged wastewater will be thoroughly mixed with the stream water, preventing deposition of solids, and the dilution takes place rapidly. In small current, the solid matter from the wastewater will get deposited at the bed of the a river or stream, and it will reduce the dissolved oxygen content at that location. Then it will reduce the decomposition of organic waste present in the wastewater, and it will create nuisance, and it will be a threat for the aquatic life. Then self-purification largely depends upon currents which are largely disperse the wastewater in the stream, preventing locally high concentration of pollutants. If the current is more, then the mixing will be more, and the presence of dissolved oxygen content will be more. Then decomposition will happen rapidly, and the wastewater concentration, that is the pollution concentration, will get reduced. And then the high velocity improves aeration, which reduces the concentration of pollutants. That is, due to the high velocity, the mixing of air with the water will enhances the process of dissolved oxygen content. Entering of oxygen content into the water body will be increased, and the DO content will be increased. This will enhance the process of decomposition or wastewater dilution. Then the sedimentation. Second process is sedimentation. Third process is sedimentation. If stream velocity is less than score velocity of particles, then sedimentation will take place, which has two effects. Here the sedimentation means the sedimented particles, that is the sediments present in the wastewater, will get deposited on the bed of the stream or river, and this will happen only when the stream velocity is less than the score velocity. The settleable solids, if present in sewage effluents, will settle down into the bed of the river, thus helping the self-purification process. Due to the settled solids, anaerobic decomposition may take place because the DO content at the point of mixture or point of the dispersion or point of dispersal will be less, and this will create an anaerobic condition, and anaerobic decomposition will happen due to the sedimentation of the wastewater on the bed of at the bed of the river or stream. Then the fourth factor is sunlight. Sunlight helps the growth of microorganism, and it will absorb carbon dioxide and gives out oxygen, and thus result in self-purification. And sunlight also acts as a disinfectant, and it stimulates the growth of algae, which produces oxygen during the photosynthesis. And whenever there is algal growth, water contains more dissolved oxygen content during daytime because it absorbs carbon dioxide and emits the oxygen content, which increases the amount of dissolved oxygen content in the river or stream. Then the temperature. The quantity of dissolved oxygen available in stream water is more in cold temperature than in hot temperature. And also the activity of microorganism is more in high temperature, and hence self-purification will take place and less time at hot temperature than in the winter. That is, in the hot temperature, the microbial activities will get accelerated, and the decomposition will happen rapidly, and the self-purification process will be enhanced. But in the cold temperature, these microorganisms will be get inactive. Then the decomposition of this organic waste will be decreased. Then the oxidation. The organic matter present in the wastewater is oxidized by aerobic bacteria utilizing dissolved oxygen of the natural water. This process continues till complete oxidation of organic matter takes place. The stream, which is capable of absorbing more oxygen, through re-aeration, etc., can purify heavily polluted water in short time. That is, this aerobic bacteria utilizes the dissolved oxygen of the natural water and decomposes or oxidizes the organic matter present in the wastewater. If the stream is capable of absorbing more oxygen, that is the mixing process, that is the aeration process, re-aeration process happening in the stream or river is more due to the mixing of air with the water, then the process of this oxidation will get accelerated, and which will result the rapid self-purification of streams. Then the reduction. Reduction occurs in the stream due to the hydrolysis of organic matter settled at the bottom, either biologically or chemically. The anaerobic bacteria will split the organic matter into liquids and gases, thus paving the way for their ultimate stabilization by oxidation. This reduction occurs due to hydrolysis of organic matter. This can be done by biologically or by chemically. By biological, anaerobic decomposition takes place, and which will convert the organic matter into liquid gases, which is non-toxic and which will not create any pollution, and thus paving the way for their ultimate stabilization by oxidation. After reduction through hydrolysis, and these product will be get oxidized, and this will enhance the self-purification process of the river. Then the zones of pollution in the river stream. That is, first zone is zone of degradation, then zone of active decomposition, then zone of recovery, and zone of cleaner water. First, we will discuss about zone of degradation or zone of pollution. This zone is the disposal point. That is the location where the wastewater is get disposed of. This situated just below the point where the sewage is discharged into the river stream. The water, the color of the water will be different from the receiving water, and the turbidity of the water will be more, and this will settle. The sedimentation will take place there, and the dissolved oxygen content will get reduced up to 40% of the saturation level, and the carbon dioxide content will increases, that is due to the chemical reactions takes place, and re-aeration is slower than the deoxygenation. That is, the dissolved oxygen content present in the dilution water and the wastewater is get utilized by the decomposition process, and the dissolved oxygen content will be less than, that is reduces up to 40% of the saturation level, and the reoxygenation rate is very low at this stage, and the conditions are unfavorable for aquatic life. Because of this reduction in dissolved oxygen content, the aquatic life is unfavorable at this zone, and the anaerobic decomposition takes place in this zone at the bottom of the river or water body. Then zone of active decomposition. Water in this zone becomes grayish and darker than the previous zone because the dissolved oxygen concentration falls to zero. That is, the total dissolved oxygen content available in the dilution water will get utilized by the waste present in the wastewater, and it decomposes, and the organic matter will get decomposed due to the presence of this dissolved oxygen content, and the total dissolved oxygen content of the dilution water plus wastewater will be equal to zero, and the methane, hydrogen sulfide, carbon dioxide and nitrogen are present in this zone because of this anaerobic decomposition. And the fish life is absent, but bacteria will be present. At the end of this zone, the dissolved oxygen content will start to rise up to 40% of saturation level. That is, aquatic life starts to reappear. That is, reaeration will happen at the end of this zone. Then the zone of recovery. Zone of recovery means process of recovery starts. That is, stabilization of organic matter takes place in this zone. First reduction takes place and these reduced products will get oxidized and the stabilization of this organic matter will take place at this zone. The BOD falls and the dissolved oxygen content increases. BOD content will get reduced due to the organic decomposition and the waste will be deposited and the anaerobic decomposition will happen in the previous zone. At this zone, the BOD value will be lesser and the DO content will starts increasing. And the NO4 and SO4 and CO3 are formed and at this stage and near the end of this zone, entire aquatic life reappears due to the reaeration process due to the increase in dissolved oxygen content in this zone. Then the next zone is clear water zone. The water becomes clearer and attractive in appearances. That is, the color fading will disappear and dissolved oxygen content will rises up to the saturation level. And the oxygen balance is attained due to aeration process and recovery is complete at this zone. And some pathogenic microorganisms may be present due to the non-decomposition of organic matter, some organic matter present in the wastewater. These are the zones of decomposition or zones of dilution. I hope you understood the portion. Thank you for listening. See you in the next class.